I am Abin Shahab I work for Altiscale, and this is Siddharth Siddhana from Hortonworks. We're going to today talk about Yarn and Docker and what the current and the future plans with Docker integration with Yarn. First, I'm going to talk about the Docker Container Executor, the new container executor that had been merged in Hadoop 2.6. It launches Docker containers in Yarn. So the issue that it aimed to tackle was tasks in node managers that run in containers. They take away one another's resources and interrupt one another's work. And we wanted a way to tackle that. Specifically, we wanted to see if there are multiple software dependencies of different tasks running on the same machine, same node manager, can Docker provide a solution to that? And so I'm going to talk about how Docker solves that particular problem. In the movie Despicable Me, there's this evil scientist called Gru, and he has minions. Gru gives tasks to little minions. He gives them simple tasks like go make some eggs, go clean the kitchen, get me some bananas. And the minions run around and perform that task. Sometimes, as you can see here, minions run into fights and interrupt one another's work. So now Gru has to think about how to stop the minions from interrupting one another. So how is that related to Yarn and Hadoop? So in Yarn, how application masters and containers distribute tasks and get jobs done is similar to how Gru is giving tasks to these minions. And if we actually look in detail, say a client submits a job. Here it's a streaming job, and then the resource manager would forward that job to the application masters, and now the application masters start giving tasks to containers, and these containers run in node managers. So here in the diagram you can see there's two jobs that have spawned several containers, and two of the containers happen to run on a same machine on that node manager 3 that you can see. So now these two jobs may have different software dependency requirements. Say they depend on two versions on the same gem. One depends on a particular version of Nokogiri, the other depends on another version of the Nokogiri. So now if they depend on the node manager machine's environment to provide the two versions on the same machine, then you may have a software dependency issue there. And if you cannot support it properly, your jobs will fail. The tasks will fail, and eventually the job will fail. So now, some may suggest the distributed cache provides a good solution to this problem, and it does. It provides an elegant solution to kind of job-specific, task-specific binaries that the task can pull up and execute. However, if your binaries have dependencies, native dependencies, then it becomes quite a bit harder to ensure that that particular binary has a particular native dependency available in the machine when there's different binaries and different jobs requiring different native dependencies. So is there really a solution to this software dependency issue? So the solution that we propose is this new container executor, and it launches Docker containers. It's submitted in Hadoop 2.6. So how does this actually solve the problem? So when you are launching kind of a Docker container, it looks for its dependency not in the host system's file system, but in its own file system. So in this case, when there are two Docker containers running, and they're running their own tasks, the gems that they need do not have to be in the node manager's file system. They have to be in the container's own file system. And these files, the file systems are completely isolated from the node manager's file system. So they can have any software that they want. You can run a MATLAB job with its dependencies and an R job with its dependencies concurrently on the same machine. And I'm sure some of you may have fielded these kind of requests from your data scientist customers. So other than this software dependency, Docker also kind of provides resource isolation. And let's look at that a little bit more closely. When you look at a machine, a node manager machine, it provides certain resources. It provides CPU and memory. It provides network. It provides users. And it provides a file system. And the tasks that you launch in that node manager share these resources. The different container executors have different ways of sharing these. When you launch a task in default container executor, it can run as the root user. So it has root-like privileges like shutting down a network interface. And it is not bound by kernel rules of CPU and memory to kind of prevent it from interrupting other tasks. So the task that runs in default container executor may be able to take CPU and memory from other tasks that are running on the same machine. Linux container executor improves this quite a bit. Now you're running as a deprivileged user, so you cannot destroy another container's network interface or destroy any host's systems. So now you're also bound by cgroup rules that prevent you from taking away CPU and memory of other containers. What Docker container does is it provides its own file system over this. So now you can have any software that you want, and you can run it in the environment that you want. So as a developer of an application that will run on a cluster, you can develop your application in your own environment, make that environment, kind of tar up that environment as a Docker image, push that Docker image into the cluster, and now as long as that Docker image is available in the cluster, it will run and it will provide you the same environment that you had developed your application in. So that's what Docker container adds over the LC right now. Now my colleague Siddharth is going to talk about the other initiatives with Docker and Yarn and where we are going with this.
Thanks, Abhay. Can you guys hear me? Okay, that's better. All right, switching gears a little bit. There are a couple of other Docker-related projects in Yarn that we have been looking at. The first of which is Docker on Yarn via Slider, and the second project that we have been looking at has been Docker on Yarn via Kubernetes. So let's take a look at each of these in turn. Now, Docker containers on Yarn via Slider, right? So what is Slider? Slider is an in-incubation project in Apache with one goal. And this goal is to make it easy to deploy and manage applications in a Hadoop cluster with Yarn. And Docker fits in nicely with this story, and let's see why. So when it comes to deploying applications via Slider, what you do is you create what is known as a Slider application package. Now, this application package basically includes a bunch of application artifacts, and along with that, a bunch of metadata that describes how this application should be deployed on the Yarn cluster. For example, you may need 5 instances of it. You may have a master and slave, and you might also need to make sure that all of these are running at all times. So when you use the slider CLI to package this up and deploy on a Yarn cluster, what the slider CLI does is it talks to the Yarn resource manager and then basically spins up a slider application master. Now this slider application master turns around to Yarn and basically requests for resources for a bunch of containers. Now, once these resources are allocated and Yarn spins up these containers, what's running inside these containers is what is known as a slider agent. This slider agent then uses the application artifacts that you bundle with the application and then spins up the corresponding processes and manages their life cycle. So when we add Docker into the mix here, what the slider agent does instead is it talks to the Docker daemon and says, run this Docker container using this image. So the way Docker helps here is that instead of having to repackage your existing application as artifacts, what you do instead is just use an existing Docker image, and then you can basically run this on top of Yarn. Now, the second project here is running Docker containers on Yarn via Kubernetes. Now, Kubernetes is a container application orchestration engine that Google originally created. It basically lets you run what are known as pods of containers. So pods are a cooperating set of containers. Think, for example, an application container versus a logging container versus a monitoring container, right? There are many scenarios where you sort of bundle these together as one unit and want to be able to schedule and deploy them. So Kubernetes lets you do that. It also has the notions of replication controllers, which let you specify how many instances you always need to be running, what are the minimum, maximum, what are the container lifecycle properties and things like that. Now, what we did when integrating Kubernetes with Yarn was to rewrite the scheduler part of Kubernetes, where we basically implemented an unmanaged application master, which would delegate resource requests from Kubernetes to Yarn. So what you could do is in Kubernetes, you could basically say, spin up this pod and run 10 instances of it. So corresponding to the resources required for each pod, the scheduler would then turn around and ask Yarn for the corresponding resources. Now, once these resources are allocated, you basically go and return that information to the Kubernetes API master, which then delegates to its equivalent of node managers called kubelets, and they basically spin up these pods and manage the container lifecycle. So Yarn has a unified resource view of the entire cluster, but the lifecycle of Docker containers in this case is managed by Kubernetes itself. Now we have basically talked about these three different approaches. So let's go through what some of the limitations of these current approaches are. So when you look at Docker Container Executor, it requires the entire cluster to be running only Docker containers. Because of the way the Yarn node manager works today, you basically have to switch your executor out from LCE or default container executor or Windows secure executor on to Docker Container Executor, and every application basically runs inside a Docker container. This may not necessarily be what you want. It also does not yet support secure mode or C group-based resource handling. We could make Docker Container Executor a child of LCE to sort of reuse the functionality that LCE provides, but this brings with it its own set of problems. Now, when we look at the current slider and Docker integration, this currently bypasses the Yarn Docker integration completely. Since it talks to the Docker daemon directly, Yarn doesn't have any knowledge of these running Docker containers, right? Now, Docker containers run as child processes of the Docker daemon. Now, the problem with that is whenever Yarn tries to monitor resources, it only sees the agent and doesn't see the Docker container spun up by the agent, because those are child processes of the Docker daemon. Now, when we look at Kubernetes and Yarn, Go Hadoop is still not ready for prime time. It doesn't support secure mode. We basically added SASL and simple auth support recently, but it still in no way matches the number of features the thick Java clients provide. In addition to that, it sort of still requires you to run two different container management systems on the same cluster. You could technically isolate the Kubernetes part of it, say using node labels, and say that this part of the cluster is only running these Docker containers, but it doesn't always work well, and you still have to find mechanisms in which you map the abstractions that are supported by Kubernetes and map them onto what's supported by Yarn. So what we did at this point was we said, okay, we took a holistic look at all of these different approaches, and we tried to figure out how we can add better support for Docker in Yarn. So what we did was we came up with the notion of container runtimes in Linux Container Executor. So basically, the notion of a container runtime is it's a low-level abstraction and an associated implementation that lets you manage container lifecycle. So Docker would be one example. Other examples could potentially be Rocket, or if there were to be an AppC specification, something implemented based on that, or LXC, things like that. The current mechanism of how we handle container start-stop is moved into its own runtime, and we call it the standard runtime. Now, on top of this, we introduced a Docker container runtime that manages Docker containers. Now, what LCE can do here is that it can delegate to either runtime on a per container basis. Now, clients specify which container, clients and applications specify which container type they want to be able to use. This is currently done via environment variables, but at some point, we hope to be able to do this via well-defined client APIs. Moving on. So the Docker container runtime itself in Linux Container Executor. So it's important to remember that here LC still manages resource isolation and enforcement. We already support CPU, we support network, there's disk. Memory is not yet managed by C groups in Yarn, so we'll defer that for a later point of time. Docker uses the C groups that are created by LCE, and we can basically pass it on to Docker run using the new C group parent mechanism that was introduced in Docker 1.6. NetCLS support, which is actually used for network isolation in Yarn, isn't actually supported yet in Docker. It's supported in libcontainer v2.1. Hopefully, it will be merged in for Docker v1.8. From what I could tell, it wasn't a part of the recent RC builds for 1.7. You can also ask Docker run to basically run the container as a specified user. Now, one other important aspect to think about here is how you manage registries and the distribution of Docker images. So while we don't necessarily have a solution for running a registry itself yet, what we plan to do in the interim is use HDFS, which is already proven to be a scalable object distribution mechanism to distribute Docker images. So what you could do is you could basically localize images before the container is spun up. And then you can use Docker load, which takes this tar file archive and then loads an image out of it. It does have certain disadvantages because when you use Docker pull or Docker run, it only gets the delta in terms of layers and only the changes you need in case you have the underlying images available already. But on the other hand, it does mean that you don't necessarily have to run a separate Docker registry. You could have a set of blessed images already available on your HDFS cluster, and then you can download them and run Docker containers. So demo time. So what we'll do is we'll basically put all of this together in all the Docker container runtime stuff and show you how we'll run MR jobs both inside and outside Docker containers. We are using a custom Docker build because we wanted to use the NetCLS support that's in libcontainer v2.1.0. Hopefully, we won't have to do that once Docker 1.8 is out. We'll also show you software isolation using Docker and Yarn, using application dependencies that are not installed on the cluster. And we'll also show you on top of that software and resource isolation using Docker and Yarn.
So this is a demo for the Docker container runtime in LCE. So for this demo, what we're going to do is we're going to use a cluster that has one resource manager, two node managers, and each of this node manager is running a custom Docker installation. Now, what we're going to do first is basically run a simple PyJob outside of the Docker container runtime. So do this. Then we'll take a quick look here, and we can see that only Yarn containers are being spun up at this point to run this MapReduce job. wait for the job to finish. Should be done any second now. Okay, so now what we are going to do is that we are going to tell Yarn that it should now use the Docker container runtime instead. So here you can see that there are a bunch of environment variables that are specified in each container. So you can see that the container runtime being chosen is Docker and the image name is specified as well. So what we'll do now is run this. Going back to looking at the containers, you can see that Docker containers are now being spun up as well. In both of these ones. So we'll wait for the job to finish. And these containers, both Docker and Yarn, eventually die. Right, so all the containers are dead. So it's basically an identical jar that is being used in both of these test cases. So now what we'll do is we'll take the next scenario, which is trying to run an application that has some dependencies in terms of software packages. So one such simple example would be if we want to figure out the amount of available bandwidth on a given node. So what we'll do is we'll run a simple IPOF server somewhere, and then in a Yarn container run an IPOF client to figure out how much bandwidth is available to us. So let's take a quick look at this. So basically this is running distributed shell, and it's running an simple IPOF client pointing to the server where the IPOF server itself is running. So let's run this. Take a few seconds to run through. I will see that here the application file. Now let's see why. So if we fetch the logs and basically look at the output, you'll see that the IPERF command was not found. This is actually because on the cluster itself, IPERF is not actually installed. So the way we'll work around this now is to specify a Docker image that has IPERF installed and run the same application. So it's basically identical, that we are running an IPERF client. The only difference is now in the shell environment, we are specifying which container runtime to use and which image to use as well. So let's run this. This time, we'll take a look. You can see that one Yarn container has been spun up. Now there are two Yarn containers, and one of which is a Docker container. The interesting thing here is that the distributed shell application master itself is running inside, it's not running inside Docker, it's running basically in a standard Yarn container. On the other hand, the IPERF application is running inside a Docker container. And you can see this time that the application completed successfully. So let's take a look at the output again. Now you can see that it's reporting roughly 900 megabits per second in available bandwidth. The server will basically show you the same. Now what we are going to do is we are going to actually enable outbound bandwidth resource management in Yarn and see how we can still use the same Docker container and use the resource isolation and enforcement that is enabled in Yarn. So quick look at the configuration difference, you'll see that network as a resource has been enabled. The outbound bandwidth available on the node is set to 1000 Mbit. And the total outbound bandwidth allocated to yarn is set to 50 Mbit. So now we are going to copy this over. We're going to do the same here. And then restart the node manager. Okay, now that the node manager has been restarted, we're going to watch for containers again. Coming back here, now we'll basically run the same distributed shell application, Docker containers. So the AM has come up, and now the Docker container has come up as well in a different node. We'll wait for the application to finish. Let's see what the IPF client reported. Now in this case, you can see that it's reporting 50 Mbit per second, which is what we set as the total outbound bandwidth available for yarn. So with this, you can see that we can use the Docker container runtime to do both software isolation as well as resource isolation in yarn.
So yeah, so that's basically the end of the demo. We have about 10 minutes left, so if there are any questions. Sure.
Great stuff, guys. About monitoring, have you looked at integrating something like Advisor into your application pipeline service? Does it make sense?
Yeah. Yeah, so the question is whether we have considered looking at integrating stuff like Advisor into the yarn application timeline service. I don't know the answer to that. Maybe Vinod will know.
So we basically introducing an abstraction on each machine to get all sorts of statistics, and CFS is one of the mechanisms, right? Depending on the OS, you may have a different mechanism on Windows, etc. So it's not integrated right now. The timeline service is today driven off, the stats that we already collect using our existing mechanisms, but that's one of the options.
So underneath, what Advisor actually does is just look at the C groups that are created by the container, by the Docker container, and monitor based on the counters that C group provides. So some of that, I think, are already being done by Yarn, especially if the Yarn is providing the C group itself. So you kind of get some of that already.
I think there's somebody here before.
Oh, right.
Yeah, I have a question. What if the yarn resource manager has a 10 minutes timeout to do the localization? What if the user upload the image? The difference can be larger than 10 minutes when you download it. So how we handle that situation?
So to repeat the question is, what do you do in case the image localization takes more than 10 minutes? Well, we haven't sorted that out yet, to be honest. Right now, the images we are looking at are small enough that you're able to localize them quickly. So if they are even in the low gigabyte sizes, it's fine. But if it's any more than that, yes, there is the risk of localization timeout. We haven't resolved that issue yet. Preload? So we could technically preload images on individual nodes, you're right. But the trouble with that is that if you're running a 1,000 node cluster, you may distribute multiple gigabytes of data, or even tens of gigabytes of data. And there's low probability that any given node might end up using it.
So one possibility is that you can check whether you already have the image, and thereby kind of amortize. I mean, first time you're going to have to pay the hit, but then you amortize across every container that uses that image across the lifetime of that node.
Do we have any
So to repeat the question, should we
That's-
consider data locality? That is an interesting point to think about.
Yes.
In terms of if the image is already present, maybe we should schedule the container there.
Yeah, you can even go farther, say that doing it the Docker way, you can calculate deltas of, okay, you have image A and I need image B, find the node that has a minimum delta and go there. But yeah, there's a lots to do in this project. We haven't gotten there yet, but that's definitely an interesting idea. Thank you for that.
What are the challenges with supporting secure clustering? I assume that's on the timeline.
Yeah, so the question is, what are the challenges with respect to supporting a secure cluster? So there are two aspects to this. One aspect is the security story of Docker itself, and we already know that there are certain issues around that front. The other part is security from a yarn perspective. Now, because LCE is able to specify which user a container is supposed to run as, we sort of just pass that around to Docker, and it basically runs it as that user. So by default, security is supported with this runtime from a yarn perspective. What that means from a Docker perspective, yeah, we still have to resolve that. We have to see if all the security issues have been fixed and it's ready for production from a security perspective.
So we're waiting on Docker.
Right.
Do you guys have a timeline for when you think you're going to?
Oh, actually, I should have mentioned this. We are targeting this runtime stuff for Hadoop 2.8. That's the plan.
Yep.
Anything else? All right, thanks, folks.
Thank you. Thank you for coming.